which is called as normal distribution. What do you mean by normal? So let me explain it using paint here. I'm trying to open a new plot. Is a request. Yeah. Practice makes you perfect. If you find this kind of a probability distribution, it is called as normal. Say you have started plotting the heights of people. The number of people whose height is 3 feet would be very less. Number of people whose height is 4 feet, you might, there'll be slightly more than 3 feet people. The number of people whose height is say 4.5 feet, you'll find slightly more number of people. Number of people who have 4.8, 5 feet, 5.5, 5.1, 5.2, 5.3, 5.5, 5.6, right? Then 6, 5.8, 5.9, 6 feet, right? As in how you keep increasing the height, and if you try to collect the data of people who have so much height, then as in how you keep increasing 6.5, it'll be decreasing again. 6.8, 6.9, 7 feet, 7.1, 7.2, 7.3, 7.4, so on and so forth. Majority of the people would have a height which ranges from say 5 feet to 6 feet. There will be very less number of people who will have a height which is 3 feet or less than that. Very less number of people who have a height which is 7 feet or above. And as in how you go to the extreme sides, very less height or very high height, the count would only decrease further. And this is the natural phenomena, right? This is naturally occurring phenomena. Hence it is called as normal. This is normal. This is normal situation. This is how the population of the world is divided into. Right? This is pretty normal. There's nothing abnormal about this. Hence, this is called as normal distribution, normal probability distribution. Right? Now, if you try to do the same thing with the weights of the people, I'm speaking about fully grown people, say 30 years, everyone is of 30 years. All right. So if you start plotting the weights of the people, right, fully grown people, there'll be very less number of people whose weight is 20 kgs. If you go with 30 kgs, it might slightly increase. If you go with 40 kgs, it will further increase. If you go with 50 kgs, okay, that's kind of normal. Most men are of that weight. 60 kgs is also normal. 70 kgs, 80 and 90, this is the range where you find majority of the people who have those weights. And then if you keep increasing, right, 100, 110, 120, most women fall into that category. 120, 130, 140, 150 kgs, 160. As in how you keep increasing, the number of people with so much weight will keep reducing, right? And wherever you see a peak, that is where the majority of the population lies. Say some 55 kgs to 95 kgs. Majority of the people will weigh within this range. Otherwise, if you look into a fully grown individual who has very less height, you will see a small portion of people. And here also very heavy weights, you will see a small portion of people. However, majority will fall in this range. This is a natural thing, right? This is a normal thing. Hence, it is called as normal distribution. There is nothing abnormal about this. Okay? Are you getting me? Any naturally occurring thing, etc., if you try to plot, it follows a normal distribution. Normal distribution itself says everything is normal, there is nothing unusual about this, and there is nothing abnormal about this. Perfect. Okay. It depends on the scenario, Kiran. This is just an example that I've given, but we will look into that. From tomorrow onwards, when we start Tableau, we will draw a histogram, we will look into the distribution of the data, right? We will do all of these. Given a data set, this plot is automatically given to you. Based on that, you try to see whether your business is normal, is working or operating as normal. Are your profits normal? Are the number of products getting sold normal? Or is there anything abnormal about it? Right? You'll come to know about all of those. All right. Each normal distribution curve can be represented using mean mu and standard deviation sigma. What does that mean? So let us consider this blue curve, which is a normal distribution curve, and you have a mean 0 and standard deviation 1. For a given data set, say sales of some product, if you take the average at 0, standard deviation is 1. If you let the average remain as is, and if you reduce the standard deviation, right? If you reduce the standard deviation, what am I trying to do? I'm trying to reduce the variation in the process. Standard deviation is nothing but square root of variance. So if I reduce the variation in the process, what would happen to the curve? It will become thinner. If you see this brown curve, average remains the same, mean did not change, this line did not change, but it has become thinner. It's thinner in comparison to the blue curve. Now, if I let the mean remain as is, mu equal to 0, and if I increase the standard deviation, look at what's happening. Look at this green curve. The width of this green curve has increased, though it's remaining at the same location as your blue curve because mean is the same. You have increased the variation, hence the width of this green curve has increased. Right? Now, if I remain the standard deviation as is, as that of your original curve, and if I change the mean from 0 to -1, what happens? You are shifting this curve from this blue curve to the orange curve. Why? Because I told mu equal to -1. It moved the curve to the negative direction. If the same curve which has mu 0 and sigma 1, if I change the mean to 1 and let the standard deviation remain as is, then the width will remain as is, but this blue curve is moving towards a positive direction, and that's this green curve. So any normal distribution curve, any curve that you draw, any curve, whatever be the width, whatever be the height, it can simply be represented using your mean mu and standard deviation sigma. If I just tell mean is so much, standard deviation is so much, you'll be able to draw a curve. That is what it means. And remember the temple bells or the Christmas bell? On similar lines, this curve, all of these curves appear as if they are bell-shaped. And this normal distribution has these properties. Have you guys heard about Six Sigma? Yeah. What is the definition of Six Sigma? Pankaj is an expert on that, right? Haven't heard? Definition of Six Sigma is 3.4 defects per million opportunities. Right. Parts per million or defects per million opportunities. Though wrong, I'll explain in a layperson terms, right? Though wrong, I'll explain in layperson terms, right? For your understanding, it's good enough, right? Okay. If you're manufacturing a million shirts, there should be only 3.4 defects. If I'm sending a million emails, only 3.4 emails should bounce back, right? And that is called as Six Sigma. Can I apply the Six Sigma to airlines industries? Can I apply it to airlines industry? Pankaj says yes. So do you say that airlines is operating at Six Sigma? Absolutely. Airlines industries operate at a Sigma level, which is much, much higher than Six Sigma. A few books say airlines industries operates at 8 Sigma. A few other books say they operate at 9 Sigma. A few other books go on to say they operate at 12 Sigma. If airlines industries operates at Six Sigma, do you know what happens? Within a week, a million flights take off and land. That means within a week, you would be hearing 3.4 crashes. If you switch on your news channel, all that you'll be hearing is, hey, there's a flight crash there, there's a flight crash here, so on and so forth, right? Hence, your Six Sigma is, companies which deal with the health of the people would operate at Sigma level much, much higher than Six Sigma. All right. Say your process is operating at plus or minus 1 sigma. That means 68.26% of your end products meet the customer requirements. That means, say you're manufacturing 100 cricket balls. Out of these, approximately 68 cricket balls will meet your customer requirements. And what is the customer requirement? Cricket ball circumference should be within this range called 229 to 224 mm. Right? And if you're operating at plus or minus 2 sigma, then 95.44% of your products will meet the customer requirements. That means if I'm manufacturing 100 cricket balls, approximately 95 cricket balls will meet this customer requirement of 229 to 224 mm. And if you're operating at plus or minus 3 sigma, that means 99.73% of your cricket balls will meet your customer requirements. 99.73% plus or minus 3 sigma. Can I call this as 6 sigma plus or minus 3 sigma? 3 sigma on either side. Can I call this as 6 sigma? No, right? So this is a frequent mistake which people do. If you have 3 sigma here and 3 sigma here, all put together, you do not call it as 6 sigma. Instead, you call it as 3 sigma process. In order to call this as 6 sigma process, from the average, towards one side of your specification. Say the cricket ball circumference should be anywhere between 229 to 224 mm. So from this mean towards one side of your specification limit, if there are 6 sigma, then it's called a 6 sigma process. And that is what is explained here. And if you operate at 6 sigma, approximately 99.999% of your products will meet your requirements, will meet your needs. Is that clear? Approximately, absolutely. Is that clear, friends? Or do you have any doubts? Yeah, it's clear. Do not hesitate, please. You can use a private chat if you feel that you do not want to open up before anyone. You can use a private chat message. But the idea is no one goes from the session without understanding a concept. All right, great. Okay. Two more quick concepts rather than starting off with Tableau today, right? I would like to show you quick two concepts and then we can break and tomorrow we can start off Tableau fresh. All right. So what do you think is a probability associated with a single value? For example, you're predicting the climate and you're saying that the temperature tomorrow would be 30 degrees, 30 degrees Celsius. What is the probability associated with this number? Someone is predicting, weather department is predicting and saying that tomorrow the temperature would be 30 degrees Celsius. What is the probability associated with this number? 0.5 Smithies? Binary is what Pankaj says. No, it's 0. Probability associated with any number is 0. It can never be 30 degrees. You always have to represent a range, right? You always give a range. Probably you will say that temperature can be anywhere between 10 degrees Celsius to 35 degrees Celsius. Now, for this range, you can have a probability associated. But probability associated with a single number is always 0. Remember that. That is what this point says. Right? And this curve, right, whatever curve that you try to draw, though it appears as if it's touching the line, it would never touch the line. It would go until plus infinity. Here it will go until minus infinity. You might, it might so appear for you that the sky is touching the ground, the earth, but that never happens, right? In a similar fashion, this curve, you feel as if it's touching the line, but it will be from infinity to minus infinity always. That's this point. The normal random variable takes values from minus infinity to plus infinity. Okay. And if I'm going to say that temperature can be anywhere between minus infinity to plus infinity degrees Celsius. What does that mean? Now, what is the probability that the temperature will fall within this range? 100%, right? 100%. If I give you this range, if the weather department says tomorrow's temperature can be anywhere between minus infinity degree Celsius to plus infinity degree Celsius, what does that mean? That means that whatever be the temperature, it will fall within this range. That means the probability associated with temperature falling within this range is 1. Hence, when you draw this kind of probability distribution plot, the area under the entire curve will always be equal to 1. It will be always equal to 1. Clear? Right? So two key things. Probability associated with a single value is always 0. So if your senior management comes to you and says, what do you think will be the next quarterly sales? You should not say it will be $1 million. Always give a range. If I ask you how much time does it take for you to uh, go to office tomorrow, you cannot say 30 minutes. You have to give a range. It might be anywhere between 20 minutes to 35 minutes. Only that statement is valid. If you give a single point, and if the manager with whom you're speaking knows ABCD of statistics, he would say, what is the statement that you're making? So the probability associated with a single value is always 0. The area under the entire curve is always equal to 1. All right. So let me also explain you about standardizing, and then we'll stop. What do you mean by standardization, right? And then we'll stop. Okay. Say I have weights of people in kgs, say 60 kgs, 75 kgs, 82 kgs, 90 kgs, 68 kgs, 190 kgs, 60 kgs again, say another person is 78 kgs, so on and so forth. Now, if I give you such million records, would you be able to assess those million records? And would you be able to tell me on whether this data point that is entered, which is 190, is not in kilograms? The person who has recorded has accidentally recorded this in pounds. Rest of all the entries are in kilograms, with exception to only this value. Can you find out this? If I give you a million records, this data is say historical data dated back to 2000. Even if you look into your bank, if you look into the various transactions which have happened, right? Say there are millions of transactions and you have the data since 2000. There is one data point within that, or say 5 data points, wherein instead of thousands, you see lakhs or you see crores. So you cannot really pinpoint and say whether that's a data entry problem or was that a real value. Because anyways, units will not be given. It will only be mentioned. This is only for your understanding. It will be mentioned in this way, your data set. Here, beside weight itself, it will say kgs. Now you don't know whether this is right or wrong. Hence, in order to solve this kind of problem, we use a technique called as standardization. How do we standardize the data? Formula is simple. Z equal to x minus mu divided by sigma. Right? Z equal to x minus mu by sigma. So you need to calculate what is mu first. Mu is nothing but the mean or average. So average of this data set is 87.875, and you also need to calculate the sigma. Sigma is nothing but standard deviation. Standard deviation for this data set is 42.56. Now, how do you calculate the standardized values? It's x minus mu. So it's x minus mu divided by sigma. You get one value. I'll repeat it. It's x minus mu divided by sigma. You get another value. So if you keep doing this, x, bear with me because this is Mac. I could not figure out until now on how to make a particular value stable. So I'll have to do it constantly. No, it's not working. I tried it, Bima. F4 doesn't work here, Pankaj, because this is Mac. It works on Windows, right? This is Office for Mac, so it's not working. And I tried out $sign also, but unfortunately, this is the only option that I'm left with. Anyways, it'll be a good exercise for you all also. So it's x minus mu divided by sigma. It is x minus mu divided by sigma. One last one, okay? It is equal to x minus mu divided by sigma, right? Now, this is unitless. Here it's represented using kgs, and accidentally someone has put it in pounds, which you do not know, which you cannot analyze because a person has taken this measurement way back in 2000. He has died now. He expired, right? That particular employee met with an accident, he's expired. So you have no other way to find out whether this is right or wrong. In reality, you might find an obese person who might be weighing 190, we don't know, or this might be wrong. Hence, in order to deal with that, we have standardized the data. When you standardize the standardized data has no units. Now, if you take an average of this, sorry about the sound. If you take an average of this, the average will be, 1 second. Hmm. Sorry, that was my kid. So if you find out the mean will be approximately 0. And if you find out the variance, or sorry, the standard deviation will be approximately equal to 1. What does this mean? 3.1225, multiply it with, so 3.1225 multiply by 10 raised to the power minus 17. It will be 0.000017 zeros followed by 31225. It's approximately 0. So whenever you standardize the data, mean will be 0 and variance will and standard deviation will be equal to 1. This is a property of standardized data, right? And we often in statistics work on standardized data to ensure that we do not get into the units business and try to do the conversions and all that. We deal with the standardized data.